Hi, welcome to the EP Biology review. We are going to cover 1.1 today, which is water and hydrogen bonding. As we know that water is a polar molecule, and here what happens that here oxygen being electronegative element, it develops a partial negative charge, while the hydrogens being less electronegative, they develop a partial positive charge. So there is a dipole which has been generated over here, which makes the water molecule a polar molecule. Because electronegativity is a property where what happens, the element has a property, has an attraction towards the electrons of other element as well. So the oxygen will pull up the electrons which are present on the hydrogen as well. So that is why this develops a negative, while these hydrogens will develop a positive charge. So that is what we are going to cover because of this the polarity of the water, what is going to happen. That's what we are going to see today. So we are going to cover the structure and chemical properties of water. In addition to that, we are going to see the hydrogen bonding. So water is a polar molecule, as I had just mentioned, and polarity is nothing but a molecule with the uneven charge distribution, which means we know that it's a covalent bond. So this is a covalent bond, but this one is which kind of covalent bond? A polar covalent bond. Like if I give you an example that if you have both oxygens or both hydrogens, so when they will form the bond, that is also a covalent bond because that is also being formed by the sharing of electrons, but they have the same electronegativity. So these are the non-polar molecules, but water becomes polar because of oxygen's higher electronegativity. So this will pull the electrons towards itself, develops a negative charge, forming positive on the hydrogens. So molecule with uneven charge distribution is called as a polar molecule, and hydrogen bonds will form between the hydrogen, the positively charged hydrogen, and the negatively charged oxygen of another molecule. So the hydrogen bond is a weak bond which forms between two molecules. So this is a kind of intermolecular force that forms between two molecules. Negatively charged oxygen and positively charged hydrogen will attract each other and they will form a weak bond. That is what we call it as the hydrogen bond. And because of the hydrogen bonding, there are so many properties which are going to get affected, and that is what we are going to cover now. The first one is water being universal solvent. Water is known as the universal solvent because it can dissolve wide range of compounds. Like we have salt here, sodium chloride, right? So for example, you have sodium chloride. So this ability comes from the polarity only because we know that in the polarity what happens, oxygen develops a negative while hydrogens develops positive charge. So this is an even charge distribution and that leads to the hydration of the ions. So we know that if you have sodium chloride NaCl, so it will have two ions, sodium cation and chloride anion. So this anion will be surrounded by partially charged positive hydrogens. So all hydrogens will face towards this oxygen, which is negative because positive negative will attract each other. On the contrary, the positive sodium ion or the cation that is being surrounded by all oxygens. See, all the oxygens will face towards the sodiums, making it more dissolvable. So there is a lot of compounds or the molecules will get dissolved in the water. So then next property is cohesion and adhesion. Cohesion is, as you can see here, cohesion, this is cohesion, where, so it is attraction between water molecules, and adhesion is nothing but the attraction between the water molecules and the other substance. And this is how what happens, this is the property with the help of that water rises in the stem of the plants. That is how water rises, and the plants, they get the water from the soil because of this attractive force only. And this leads to the surface tension as well. So what is surface tension? The surface of water, it acts like an elastic sheet over here. So because of that, what is going to happen? That you will have, like you can see here, because of the water's rounded shape, the droplet takes a rounded shape, or the water surface is so elastic that the water strider can walk over the surface of the water. That happens because the water molecules have these hydrogen bonding between them, and that is how the water molecules are attracted to each other, and they will form an elastic surface. So that is what we call it as surface tension. Next property is density. Now, density of water versus density of liquid water and ice. So as we can see, this is the liquid water molecule, and these are the snowflakes, or the when the ice has been formed. So in liquid water, molecules are very closely packed, which makes the water denser. While if you look at this frozen molecules. So when the ice crystals are formed, they will make a crystal structure, and they will have a lot of space in between. And because of this space, their density would be lower as compared to the liquid water. Here the density is greater, while here the density is lesser because of this space which has been created between the molecules. So this is how we can explain the density. And in addition to that, you have the high specific heat. I must tell you, specific heat is the amount of energy which any compound requires to raise its temperature by 1 degree. So you have taken 1 gram of substance and you try to heat it up, and you want to raise the temperature by 1 degrees Celsius. So in case of water, since the hydrogen bonds are present, so first your little amount of energy, a lot of energy will be utilized in order to break down these bonds. So first you need to break down these bonds, and then only this energy will be used to heat up or raise the temperature. So that's the reason water has a very high specific heat as compared to other substances. And the last point over here, which is pH. So pH is nothing but a measure of acidity or basicity. That means it gives you a range from 0 to 14. This is the pH scale where you can see 0 is minimum, which is maximum. The acidity is maximum over here. And the 14 pH is most basic, and 7 is neutral. So 7 pH is neutral pH. So the body fluids, the water we drink, that is nearly 7, while as you move down towards 0, the acidity would increase, and as you move up towards the 14, the basicity would increase. And you can calculate the pH on the basis of hydrogen ion concentrations. I'll give you an example. Suppose you have water or you have HCl. So in this case, what happens? Their capability to give this hydrogen ion. So they will form H plus and OH minus. This will form H plus and Cl minus. So whatever compounds you have, so their capability to give this H plus ions, that makes it acidic, and the pH can be calculated by the negative log of the hydrogen ion concentrations, which is being found in your solution. So further, thank you so much for listening. And if you have any further questions or need some more information regarding this, feel free to ask and stay connected to continue with 1.2 and the further units before your AP exam. Thank you so much.